Hello everyone, I am James Hopfenblatt. I'll be presenting this research on behalf of my research colleagues, Jayedi Aman, Nusrat Tabassum, Dr. Jong Kim, and Obidul Haque. Our research topic is Optimizing Container Housing Units for Informal Settlements, a parametric simulation and visualization workflow for architectural resilience. Presently, module-based housing made of recycled containers is getting attention in the building industry. Worldwide, over 17 million used shipping containers exist due to the globalization of supply chains. This surplus has initiated a trend in construction units for architecture, like the ones you can see here. This movement is the same in developing countries such as Bangladesh. Bangladesh has seaports and river ports, which prompted container housing units to become popular among urban wetland dwellings. Residents in these wetlands construct self-help houses using either locally sourced materials or recycled containers. They place their dwellings in unplanned arrangements without considering the impact of the surrounding environment or ecology. For this reason, our main motivation was to develop an optimization-based informal settlement framework, keeping the dwellers in the loop. The aim of this research was to provide an in-depth assessment of container design optimization to achieve the sustainability goals set by the United Nations. The research framework was developed in 4 steps. First, we selected the container cluster patterns through observing the local housing cluster and courtyard typologies. In the second step, we developed a hypothetical container cluster and chose the design variables. Then, we performed the optimization process in 2 segments. First, in step 3, we tackled the energy optimization through multi-objective optimization algorithms. For the second segment, we introduced a feedback-based micro-level space optimization procedure through gathering users' feedback. This participatory design involvement can be conducted via parametric immersive visualization. In this workflow, we use the ArcGIS platform for obtaining the existing building footprints. Then, the footprints were taken to the rhinoceros grasshopper environment. Here, we perform parametric simulation modeling using Ladybug tools. We use the Octopus plugin for multi-objective optimization. Finally, we developed a proof-of-concept virtual reality environment for the micro-level optimization phase using the Unity game engine. Let us briefly discuss about the steps of this workflow. First, we chose the vernacular building patterns in Bangladesh as the design guidance. Through surveys, we found that the vernacular housing patterns are mainly courtyard-based. Family members generally use this type of spaces for home-based activities, such as for work and leisure. They can access the building units through courtyards, which are then placed in juxtaposition to each other. Moreover, we investigated the common courtyard types. There are mainly 3 types of courtyards we can see in the vernacular architectural practices in Bangladesh. To develop our prototype, we used amalgamated courtyards with surrounding building patterns. In the development of this prototype, we also focused on the cluster typology for formulating the hypothetical module. Previous research projects identify 3 different cluster patterns: generic, existing, and hybrid, to be used for the optimization analysis. Despite advantages, we found some major drawbacks for the first 2 typologies. While generic patterns oversimplify the complex surrounding context, existing arrangements have limitations of transferability for site variation. Therefore, we use a hybrid cluster pattern, which you can see in the 3rd row. This type of cluster keeps the existing surrounding context and abstractly presents the hypothetical module for computational efficiency. Finally, we selected the Korail slum as research site where we implemented this simulation workflow. The Korail slum is one of the largest urban wetlands in Bangladesh, placed near a lake. This slum houses over 20,000 families and the living situations are mostly deplorable. Having the living units placed in close proximity people in the Korail slum generally prefer to reside in clusters. The dwelling units resemble traditional rural housing plans. Here you can see that the structures typically contain a naturally illuminated courtyard. The dwellers use the open courtyard as a multi-purpose space for cooking, playing, and socializing with visitors. In the second step, we formulated the hybrid module, keeping the existing complex site surroundings of Korail. We conducted a physical survey of 350 families, which showed that an average of 4 to 6 people live in a small dwelling unit, and about 200 people live in one cluster in the case area. We chose several design variables of container housing units for the multi-objective optimization process. The design variables were window-to-wall ratio for 4 elevations, window height, window sill, module orientation, and shading depth. We determined the range of these design variables through the physical survey in the slum and local building construction regulations. We used a Pareto front algorithm for optimization. We considered useful daylight illuminance and energy use intensity as multiple fitness objectives. This process helped us to acquire the insights regarding the best possible options and impact of different design variables on the energy performance. We also compared the optimized model with the base model to validate if the design variables can improve the current sustainable measures. Here you can observe that the optimized model can improve daylighting conditions while reducing energy consumption and reducing construction costs. This process may help the user decide the proper design variables and dimensions during the construction phase. However, when we investigate vernacular practices, we can see that computational designers often control micro-level variables such as material properties of the dwelling units, courtyard elements, and interior partitions. As the local people construct the units, participatory design can be a way to get the people involved in the early stage design process. As a result, we bring the optimized three-dimensional model to a virtual reality design environment for design customization. Here, the user interacts with a container unit where a predetermined set of variables can be modified through a user-friendly interface. With parametric virtual reality, they can feel spatially present and change the necessary variables. Here they can change the finishing materials such as color, cladding, partition location, built-in furniture arrangements, and modify lighting options. The local users have unique personal insights and contextual knowledge about their spatial preferences. However, they do not have the technical nor design background to use complex tools like Grasshopper and Revit. The people can manipulate exterior variables such as vegetation parameters and their seating and cooking locations in the courtyard. Suppose you're a dweller of one of these future units. You can use your contextual knowledge to be involved in participatory design with planners and neighbors. The interface is intended to be simple so that the users can easily control and give inputs in the early design phase. Despite the advantages, we identified several drawbacks. A conventional building performance simulation takes excessive computational time. Therefore, currently we are working on integrating artificial neural networks to the optimization process, which can minimize the simulation time and can provide real-time feedback. We may also consider other potential design variables for the container housing units. The novelty of this research lies in its approach towards parametric simulation while considering micro and macro levels of optimization. Collaboration between computational designers, architects, planners, and users can help develop performance-based vernacular informal settlements. We appreciate your time listening to our presentation. Please feel free to reach us if you have any questions.